Let's go through LeetCode number 4, median of two solid array. For this question, it gives us two solid array, nums1 and nums2, and it asks to find the median. We know the median, if it is the total number of this two array, that is an odd number, that will be the half, for example, m plus n, right? Index. And if it is even, we'll get two elements and get the average. So it will return a double type. We know the question asks us to have the time complexity should be O log plus m plus n, right? So the time complexity have these constraints. We cannot have two pointers to count, right? If we have a pointer which pointed to the zero index of number one and a j index point to zero index number two, and compare which is smaller, and then move to next until we get the 2m plus n divided by 2, and that will be an O m plus n time complexity will not be our solution. So for this question, we should have some way which should be do more efficient. So if we can so intuitively, if we want to go to O log time complexity, we are thinking about whether we can do something like binary search. Right? So to do this question by binary search it's a bit difficult than the others, because we are not binary search on those numbers. And what we are talking about is that I'm going to binary search on a delimiter position. So let's go through how we are doing this to do the binary search. Firstly, for these two arrays, I always want to have the smaller array in front. So we have int m equals nums1 dot length, and n equals nums2 dot length. If m greater than n, just swap, right? Just return, find the median, sort the arrays nums2, nums1, so that the first one will always be the smaller one. So for example, we have two arrays, right? So that the first one is the zero index from 0 to m minus 1, right? And the first one, the second one will be 0 to n minus 1, right? And we are going to search the position of the divider or delimiter, so that we have this delimiter. This part will be placed in the median of the smaller part, and this part will be placed in the bigger part. We know for the median, right? Median, that index will be, for example, 2 n plus n will be the median index, right? So if this kind of delimiter fixed, we know how many numbers of a small part in the array 1, then the second delimiter will also be fixed, right? So if this fixed, the position is fixed, this one also fixed. So what we want is that for this delimiter on the left, it has the left one, and the right, it has the right one, right? And the right one. And this one have left 2. And this one has a right 2. We find a delimiter position which have L1 smaller equal to R2 and L2 smaller equal to R1, right? We want to find such a position. So this is our goal. So this is the first thing, our goal, find the delimiter position. And the second thing I want to address is that this delimiter, the position may not be unique. Let's take an example. For example, in the array 1, right? Array 1, we have, for example, 2, 3, 3, right? And array 2, we may have 3, 3, 3, 4. And there are 7 elements. We know the delimiter, we are trying to find a delimiter here, right? The delimiter can be here because if we put a 1 on the left, and we know 1, 2, 3. 1, 2, 3, 1. And we know totally there are 4 on the left part. Then we know there is 3. The second one will be here, right? Second delimiter will be here. And this meets the position, the condition, right? So we know we can put this 2 and this 3 on the left part, and this 3 and this 4 on the right part. This meets the position condition. And also we find that the median is this 3, right? So, but if we move this to here, right? Then the second delimiter should move one position, and we can also put this 2 and 3, and this 3 on the left part, and then this 3 and this 3, 4 on the right part. So this also meets the position. The same thing if we move the first delimiter here, right? The second delimiter move here. This one we have 2, 3, 3 from the first array, and this 3 from the second array, to the smaller part, and this 3, 3, 4 to the second part. So this delimiter, if we do binary search, it can have multiple answers. So what we are going to do is that we search first delimiter position which has L1 smaller equal to R2 and L2 smaller equal to R1. Okay. So this is the next thing we need to consider about. And the third thing we want to consider about is that for this delimiter, if we put this delimiter here, right, just on its left, there is no numbers. But in the that means we select nothing from the array 1 to a smaller part. And we cannot get L1 here, right? So what we can do is that for each array, on its left, we have minus infinity or integer dot mean value on the left, right? That means if the index is before the first element, that is we select nothing from the first element. We we add we put this L number to be infinity minimal value, and also this delimiter that is at the end of the last element of the array 2. What we are going to do is that on the right, we don't have a R1 from array 1, right? We can put a number called integer dot max value to be the right number, right? So we are trying to binary search this delimiter. So let's begin to write code. We know into binary search the delimiter, the start will be 0, right? Because that is the minimum one, right? That is from here. This is start, and the end will be m, and we have while start plus 1 smaller than end, int mid equals start plus end minus start divided by 2. Here we are going to write a help function which will get these 4 numbers private. I'm going to use an integer array called get numbers. And I have numbers in numbers pass in nums1, nums2, and also delimiter. So so we'll say for this array, that is we are going to have result 0 would be L1, result 1 will be right 1, and result 2 will be AR2, and the result 3 will be R2. So we want to search the first position which have L1 smaller equal to R2, and R2 smaller equal to R1, right? So the thing is that we know if R2 is greater than sorry, so that is L2 greater, if it is greater than R1, right? Yeah, R1. That means on the second array we select too much on the left. That means on the first array we selected few on the left. So first array we need to select more. We need to have delimiter move to the right, right? That is we need to. That means the delimiter we select is too small. So what we need to do is that we have start equals mid, right? And we have else if. As if, for example, we have left 1 greater than R2, right? That means we select too much on first array on the left part. We need to have the end equals mid, right? And else is that we for this condition is that we have L1 smaller than R2 and L2 smaller equal to R1, right? So this one means this kind delimiter meet the position. But what we want to select is that we, because binary search, otherwise it will not have a unique result. It will have we need to find the first delimiter which meet this position. So we will also have and that means we still need to have this delimiter move to the left and equals mid, right? So let's these two conditions we can combine with one, right? Just have else. Okay. So R2 greater than L2 greater than R1. That is let's have int with some numbers equals get numbers nums1 nums2 and need and that is numbers 2 greater than numbers 1, right? Okay. So this is after we finish this binary search, the start in the end have one index difference. We want to find the first delimiter. So if first start we have let's get this one first. That is S numbers, right? S numbers equals data numbers 1, numbers 2, start. Okay. If we have S numbers, that is for the start we have already have L1 smaller than R2 and L2 smaller equal to R1, right? Then we just return get a median. And for example, we have this number, we can have this numbers. And if start does not meet this condition, and we have an end, right? And then just return get a median. We'll write this help function as well. E numbers. Okay, so this will be our binary search. So this one, that is numbers it is number S numbers 0 smaller equal to S numbers 2 3, right? S numbers 3 and S numbers 2 plus S numbers 1, right? Then return this median. So we are going to private boolean with median. We have int numbers. double, sorry, this is double. So this will be the structure of our function. The first one is from this delimiter, we trying to get these two arrays, trying to get these four numbers, R1, right 1, R2, right 2. So we have int m equals num1 dot length, and n equals num2 dot length. Okay. Int result equals new int 4, and return result. And for this delimiter, we know delimiter index D1, you know, D1 that is from 0 to M, right? And D2 will be from 0 to M, right? And we want to have D1 plus D2 equals to A plus M plus 1 divided by 2, right? So we know the delimiter truth index in D2 will be N plus N plus 1 divided by 2 minus DL, okay? So we have result 0 equals DL equals 0 or not. If this is equals 0, we'll have integer dot mean value. Otherwise, will be 0, 1, nums 1, DL minus 1, right? And the result 1 will be DL equals M or not, because if this equals M, it will be integer with max value. Otherwise, it will be nums 1, the next index, right? And the result 2 will be whether D2 equals 0 or not, right? If it is 0, that is integer dot mean value. Otherwise, it will be nums2 dot D2 minus 1. And result 3 will be D2 equals n or not. Because the n that will be integer dot max value. Otherwise, will be nums2 dot D2, right? So this will be the 4 values for the delimiter. And for the median, there are two kind of scenarios. Depend on the sum of M and N is not or not. Is an even or odd number. So we can have a Boolean called odd, right? Equals m plus n mod 2, whether this one equals to 1 or not. Right. So we can have odd here, right? So we can have an odd, right? So let's say if odd, we just return max L1 L2, right? So that is numbers 0 and the numbers 2, right? Without. Otherwise, we need to return average max numbers 0, numbers 2 plus max.min numbers 1, numbers 3, at this one, then divide by 2.0 because we want to return a double, right? So S numbers. There are some kind of issues. If this out, if this one is correct, then by this means we are select this. Three. We are getting if they start, we're trying to find the smallest one. Start. We should have that delimiter here, right? So that is the 1. Just trying to print what's its S start here now. What's the system? Start is 0. That means we have did we return here? Let's try to see which one we called. This should be end. Sorry, this will be end. I think we have a type of error. So this is our solution. The time complexity for this kind of approach will be O minimal M and A log, that is, for example, will be O minimal M A log log right.